This video introduces polynomials. Now, a polynomial is an expression of more than two algebraic terms, and it's the sum of several terms that contain different powers of the same variable. The powers must be whole numbers, and the powers cannot be negative or fractional. The polynomial can be expressed in factorized form because you can expand it to get the polynomial. So, when we're writing polynomials, we always need to write them in descending order of powers. So the example here, we've got x squared plus 4x cubed plus 3 plus 7x. And the first thing we need to do is identify which has the highest power, and that would be the 4x cubed. Then we're going to add on the x squared because it has the next highest power, and then plus the 7x, and finally our constant term of 3, because that is the same as x to the power of 0. The degree of a polynomial is the value of the highest power. So in x cubed plus 3x squared plus 2x plus 7, we have a degree 3 polynomial, which is also called a cubic function. If we have x to the power of 4 plus 6x cubed plus 8, we have a degree 4 polynomial, and that's also known as a quartic function. And we've already been introduced to a degree 2 polynomial, that's a quadratic, and a degree 1 polynomial, which is a linear function. The coefficient is the number in front of each power of x. So in 5x cubed plus 2x squared plus 9x plus 1, the coefficient of x squared is plus 2. So you're taking the sign and the digit in front of the x squared term, and so our coefficient is 2. The constant is the coefficient of the x to the power of 0 term, because we know from our rules of indices that anything to the power of 0 is 1. So we can write that x to the power of 0 after the 6, showing us that the constant term for x cubed plus 4x squared plus 3x plus 6 is 6. Now, polynomials are often expressed in functional notation. In other words, f of x, or the function of x, equals 2x cubed plus 13x squared plus 41x plus 62. A root of a polynomial is when that function of x is a value of x for which the function of x equals 0. So if we want to evaluate f of 2 when f of x equals 3x cubed minus 5x squared minus 4x plus 1, we can use substitution. So in other words, we're going to replace each of the x terms with the number 2. So f of 2 is going to equal 3 multiplied by 2 cubed minus 5 multiplied by 2 squared minus 4 times 2 plus 1. Now if we use BODMAS to evaluate that, we're going to get 3 times 2 cubed, which is 8, minus 5 times 2 squared, which is 4, minus 8 plus 1 equals 24, minus 20, minus 7, and that gives us a value of f of 2 equaling negative 3. Now, you must substitute polynomials with a given variable, so note if x equals h, then we can write f of h equals 3h cubed minus 5h squared minus 4h plus 1 for the above function.